I am just remembering that I never started the recording, so I'm doing that now. Can you say the question again?
Yeah, so you're like the first commit only adds the hello file.
Correct.
But then when you create your new, like the new branch, it adds in like all of the previous files. Like how come it's added even though?
So let's scroll back up here to where these changes happened. So we have these four files created right here: Hello World, Salve Mundi, and then the key thing is right here with the star e star. When we add that, we only add the hello file. So these other three files, they exist, but they are not recognized by Git. We haven't told Git about them at all. And the commit line that happens right here, this only commits the things that have been added. So it only commits the hello file and not these three files down here. Then when we go into the foo branch right here, when we do git add dot, the key thing here is the difference between this line, the add dot that happens inside the foo branch right here. When we do git add dot, that dot means add absolutely everything that's in the current folder, no matter what. Doesn't matter what its name is, whether it's a dot file or not a dot file. We add everything in the current folder. And so that matches these three things. These are the three things in the current folder, and it adds all three of these to the staging area. That's different than what we did up here, where we did just git add star e star. This right here expanded just to the single file hello. And so the master branch only knew about the hello file when we did the commit for the master branch. The foo branch is going to know about all three of these files when we do the commit for the foo branch right here. And so when we go back to the master branch, we go back only to the files that Git knew about in the master branch, and because it didn't know about these three files at the time, those files get deleted. Did that answer the question? Somewhere in there?
How can we check out the foo branch that Git isn't supposed to know about those why are they still showing up in our foo branch?
So the question is that at this line right here, we have not told Git, we have not added to Git these three files, .mundi, .salve, and .world. But then when we do the Git checkout right here, why does Git not delete those files or do something to those files because it doesn't know about them? The answer is because Git only ever modifies a file that you have previously run git add on. If you've never run git add on a file, Git will never modify that file. And there's very good reasons for that. Lots of programs just add a lot of extra files into folders that maybe we don't want Git to modify in some way. But the reason that Git didn't do anything with these files right here when we did the Git checkout foo is because we had never run Git add on those files. So Git wasn't aware of them. Yeah.
So like, hypothetically, if we did have that line, we check out the foo branch and we went back to the master branch, those three files would still exist.
Fantastic question. So the question is, what if this line right here, sorry, that line stayed, but then this line up to this line were deleted, and then we would never be telling Git about these three files in the foo branch. And so when we go back to the master branch, then these three files would not be modified. These three files are only modified right here as part of going back to the master branch because we told Git about them inside the foo branch. Yeah. Great questions. Any other questions so far? Yeah, lots of things going on in these problems, both with the glob itself and with Git and all the other things that we've seen in the shell. So complicated problems here. Let's go on to number 3. Set over to number 3. Rerun our first command, resetting the problem. And now make dir ./-a like this. I do that, and what this is doing is this dot, again, refers to the current folder that you're currently in, and then inside of this folder, we will create a file named -a. Again, if we had done something like this, then make dir would consider this to be a parameter, a flag that is being passed to it to affect its behavior. But we did not do this. We did the dot slash. So makedir no longer considers the dash a to be a flag, but considers it to be the name of a file. Another 100% equivalent thing is to add the dash dash in front of the file names that you want to add. And then every shell command will interpret this as anything after the dash dash must be the name of a file. And anything after a dot slash must be the name of a file. If I type ls down here, you can see there's a folder named -a right here. And now we do this echo evil into -a/.evil like this. So this just printing the word evil in this folder right here in a hidden file, dot file inside the -a folder. And now when I do ls star, this star is going to expand to all of the files in the current folder. One of those files is this -a right here. And so it is going to be the equivalent of running ls-a. So you get all of the dot files, including all of the regular files. So this weird behavior of the glob and how it interacts with the shell programs, that this is usually not the behavior that we want, not the behavior that we expect. We usually expect star just to be files and not modify the behavior of our programs. But if you just put a glob by itself and people have named files with evil names, then they can arbitrarily make your code do whatever they want it to do. So if you don't want people's file names to be able to affect what your programs are doing, you have to put the dash dash in front of it like that, or the dot slash in front of it like that. Question? Question is if we have dot slash star and then more file names over here. So the question is, what happens if we have a star between two slashes? Then this matches right here. Any folder in the current directory, doesn't matter what the folder's name is. And then something like this, then it has to have the word test after it. If I do that, there is nothing that matches this. I'll go ahead and makedir A, makedir B, makedir C, echo A/test, echo B/test. So there's a test file inside of A and inside of B, not inside of C. And now if I do something, make it an echo, and that dash A is throwing things off here. Arm dash 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 A dash R. This is so what's happening right here. The star/test is not matching anything for. When I ran the echo commands up here, I was just literally echoing it. I meant to output it to a file. What's happening down here whenever you have a glob and it doesn't match anything, it just the glob stays as the glob and you get star/test. What I meant was echo test into that. So now inside of A, there's a test folder inside of B. And now if I do the echo/test, it pattern matches to A/test and B/test. Did that answer your question? It is reasonably common to have this sort of pattern of putting stars, like I want every test file that is in whatever folder in my current directory. That's a moderately common thing to do. Here it's not, this glob gets expanded to all of the folders A, B, and C. There are test files inside of the folders A and B, and so it is getting expanded to these two values right here. Any questions on number 3? Last problem, problem number 4. let's reset, Control R, get my CD command back. And now another fun Git problem. Git init, makedir.test, touch dot test slash dot hello dot world. So importantly, this dot hello file is contained in the dot test folder. The dot world file is not contained in the dot test folder. And then touch dot test slash salve and moonday like this. And now we have our first interesting command here, git add dot test slash dot star. And before I hit enter here, we're going to see this is going to have really weird behavior. And when I am typing things out on the command line, and I am tempted to use the glob because I think it's going to make my life easier. And I think, like, I'm not 100% sure that the glob is going to do what I want it to do. And I really mean like 100% sure, like I'm willing to bet my life that the glob is going to do what I want it to do. If I'm not that confident, then I will use the echo command just to inspect what exactly the glob will match before I run it. So echo dot test slash dot star like this shows me all the things that the glob here will match. And so the one on the right over here is the most obvious one. Maybe not obvious, but most obvious about what it matches, that we're looking in the dot test folder, and then we're looking for the dot files in the dot test folder. It matches this dot hello file over here, and that was created right here on this line right here. Does not, for example, match this salve file in the dot test folder because there is no dot in front of salve. But then that's what's weird is that it matches the dot dot and the dot as well. And in particular, when I run git add on a folder, git add on this right here is going to, the dot is the same as not having it. It just means the current folder that your path currently references. So that's the same as dot test. When I do git add of a folder of dot test, it adds everything in the folder. So this is going to add this part right here, this first thing that it gets expanded by the dot star, that is going to add the dot test slash dot hello right here, but it's also going to add the dot test slash salve right here, because salve is inside of the dot test folder, and this glob right here matches to the dot test folder. Things get weirder though, because there's a dot dot over here as well. The dot dot over here it refers to the parent folder of this path right here. So this actually refers to the current folder that I'm currently in. And when we add the current folder that we're currently in to Git, it adds every file possible. So this line right here is going to add not just the dot test folder, not just this and this, but also the moonday and the dot world. If I run this now, actually run it, instead of just looking at that, run git add dot test slash dot star and type git status, then you can see that all the files that we've created have been added to the staging area, and nothing is not in the staging area. So this is the same git add dot test slash dot star turns out to have been given us the same exact effective behavior as what git add dot would do. That was line 6. Moving on to line 7, git commit dash m first commit like that. All 4 of those files have been added and committed. Git checkout dash b of, not gut checkout, git checkout, and then git add dot. This dot didn't add anything because everything's already been added. There's nothing left to add. And so when we do git commit dash m second commit like that, there's nothing to add. Nothing got added to the foo branch. So this goes back to the question we had before about what if you don't add or modify anything in a branch and just go back to master, then we'll get exactly what was already in master. And now if I run ls-a right here, we'll get all the files that we've created in the project folder. And it turned out none of those git commands actually did anything. That you could have deleted lines 6 through 11, just run the ls-a immediately after the touches, and things would have stayed the same. Probably like once every 6 months or so, while I'm working, I type out a command with the glob and I don't realize exactly what the glob is going to expand to, and I hit enter. And then as soon as I hit enter, I realized that the glob was behaving something in a different way than I was expecting. And I panic, and because I have just like deleted a lot of files that I didn't want to delete, or done a lot of behavior that I didn't want to do, especially with this dot star. That one always gets me. If people who were here in data mining last semester remember the Lambda server going down for a day, it was because at some point I did a dot star glob, and I did not fully appreciate what was happening. Any questions on this last problem or any problem? Yeah.
So the glob doesn't match a dot at the beginning of a file, but if you have dot bang glob, then it can match dots.
The only character that's special is the very first one on the file. So if you had, let's say we have touch a dot a like this, and let's do a b c that, and we do echo a star c like that. That does match the a or a star. That matches either of these two files right here because the dot's in the middle. So this is useful for like, there are many files that have like file extensions. So something like touch readme.md. And if I want to do like ls star dash l just to see like the long information about all the files, we want to be able to match the files that have these file extensions on them. That's an extremely common thing, but much more rare to want to match the dot files, and so that's why it ignores the first character if it's a dot. Good question. Any other questions? Okay, total up your scores and get those quizzes up front to me. Any other quizzes? Okay, the rest of today, we are in the topic for SQL folder again. And last time we did a quick overview of these high-level notes up here, and we started working on this Pagilla homework assignment, seeing the right way to go about working with that in the terminal, some good techniques to use. And we started solving the first problem, but we didn't quite finish solving the first problem. So we'll pull that up and finish up that first problem today. That's what we'll start with. Again, I have two terminal windows open down here, both in my folder that I've cloned with Pagilla homework. And again, you have to do the special cloning thing to get access to the data files, which are in a Git submodule in this Pagilla folder inside of the Pagilla homework folder. Whenever I'm starting to work on one of these problems, I'll always first run Docker PS just to see what's going on with Docker, and then stop any Docker containers that I have so they don't somehow interfere with what's going on. Easy way to do that is to run the Docker stop command and then the hash IDs over here. But I don't want to have to copy and paste all these hashes, so I'm going to use the command substitution to list those hashes for me automatically. Docker ps-qa lists all of the hashes of all of the running Docker containers, and then again, this is the command substitution. So it takes the output of whatever this program is right here and passes that as a command line parameter to this program over here. Just see what the output of this looks like. You can see here's all of my containers. And so Docker stop like that. And then I run Docker PS, and now I don't have anything running. So I know I'll be in a clean state when I bring up my container and won't have to worry about maybe I was accidentally doing something on it that put me in a weird state. So now I do Docker compose up -d, send this Pagilla Postgres into the background of Docker PS. Now I can see it's running over here, and we're ready to connect and start working on the problems. The way that we always can check our problems to see whether they're working or not is this check answers script. So I used Control R to search through my history again, and this Docker compose exec pg /check answers will run through and show me what of these problems are passing and what are failing. And again, all this information is inside of the Pagilla homework repository itself in the README, so that you'll be able to reference all of this later. Normally when I'm working on these things, again, it's nice to have an interactive session with pSQL that I can use right here. So like \d, see all of the tables that I'm working on. And then we did things like select star from actor just to actually see the contents of these tables. And then in my top window, I like to use Vim to actually look at the file itself, the problem that I'm working on, and all the different outputs. If I type ls in here, again, the 3 folders, so Pagilla contains all the data. This is a project-specific folder. It's standard in every Postgres project to have a SQL and an expected folder. A SQL contains just SQL statements, and the expected contains the output of those SQL statements. There's always going to be some sort of script that will run all of the SQL statements and compare them to the expected, making sure that the output is the same. And that, and again, when it does this checking, it's like a literal character for character check. When you first clone this project, you will not have the results repository or the results folder right here. But after running the check answers creates this results folder for you. I'm going to run ls SQL like this. There's 20 problems in here, 17 different numbered ones, and then 3 of them that have this function at the end. And we were working on this very first one, 01.SQL right here. I can open it up with SQL or Vim SQL/01.SQL. And this is where we were at the end of last class. Tying into what we were working with the quiz, I'm going to do something a little bit special here with the glob for a second. And let's do an ls of my expected. And the 01.out contains the expected results, what we're hoping to get from the 01.SQL file. I would like to open, like if I know I'm working on problem 1, I would like to open both of these 2 files at the same time. Inside of Vim, I can do Vim SQL/01.SQL and Vim expected/01.out like this. If I do that, it opens up both of those files. You'll notice that there's not 2 tabs open. Technically, these are in 2 separate, what are called buffers inside of Vim. If you want them to be inside of actual tabs, adding the -p flag at the end puts all the files that you're opening inside of 2 separate tabs. So it's very common for me to open up multiple Vim files at once with the -p flag. And now I have these 2 different tabs open that I can switch back and forth between. But again, typing out all these files by hand, super inconvenient. I don't want to do that. I just want to have to type the 01 part so that it knows that I'm working on problem 01. And then we'll use the glob to match all the rest of that for us. And this will open everything related to problem 1 for us in just one. I will call it a simple command, but feel free to put scare quotes around that simple. one simple command opens up all the files related to problem one so that I can start working on them. We have the expected file right here. I know it's expected because it has an E right here. Vim shortens the paths to file names in the tab up here so that it's readable. So here it's just an E for expected. Here's the R for results. And here is the S for SQL right here. And again, I'm pressing GT to switch back and forth between all these different tabs. And where we were at last time was that we got the results right here, the things that we actually, the actual results from our SQL command. So here's our SQL command right here. The actual results of our SQL command are in this R file right here. And they're very, very close to the expected results, the E file right here, but they're not exactly the same. And by going back and forth between them like this, I can just get a quick sort of bird's eye glance that they're very similar to each other, but they're not exactly the same. And so our next task is to figure out exactly why they're not exactly the same and fix it so they are exactly the same. Before I do that though, are there any questions about just the setup of this problem, like how I'm working on this problem or how to have a comfortable environment to work on this? Yes. The question is, does glob work inside of tab E and like colon tab E? I don't think it works, but I actually don't know. Let's try SQL/star. No, okay, it did work. There were too many file names. SQL/open SQL/ O2 star. Nope. Okay, it doesn't work. It only works if it matches exactly one thing. And if you're trying to match just exactly one thing, then tab completion is probably the better thing to use. Good question. Any other questions about the project setup? Where we're at? Or what we need to do at this point? Okay. It's going to be relatively common while you're working on these problems to come into this situation where you basically have the correct results, but the only problem is the order of things. And anytime the only problem is the order of things, it's the order by clause down here that you'll have to focus on. And so here our order by is ordering by the first name and then the last name. And if we look at both of these outputs, we can see that it seems like it's pretty reasonably ordered by the first name and then by the last name in both cases. The weird part though, what's different here is, so on line 5 right here, we have Al Garland, and Al with nothing behind it is being put before Alan in our results right here. These are our results. We're getting Al before Alan right here. And over in the expected, we're getting Al after Alan and all the other Al sort of people. And then the question is sort of like, why exactly is that happening and how do we fix it? The English up here, the English statement of the problem is relatively informally specified, that it just says sort the results alphabetically. It's not talking about all these weird edge cases. And so you'll have to actually like look at the expected to figure out exactly what the weird edge cases are. In this case, what the actual solution does, before I do what the actual solution does, I want to be able to copy this code up here, down here, and modify it to try out some different possibilities and see which one of those possibilities is going to work for us. In order to copy and paste inside of Vim between these two machines, this top one again is connected just to the Lambda server, and this bottom one is connected to a container inside the Lambda server. So their clipboards are not the same. In order to copy and paste between those two things, I will have to resort to using the mouse. Yes, shake your head. But we will use the mouse here for just a small second. And in order to copy and paste using the mouse here, you'll notice that if I try to do this, I keep trying to do it, but I keep getting all my line numbers over here. Stupid line numbers getting in the way. And if I try to paste down here and hit the semicolon, we'll get these errors based on these line numbers down here. So it's very convenient when I'm working on these SQL files and I want to copy and paste, I will turn off the line numbers, :set no number, and now I can easily copy and paste down here and more interactively explore what my problem's doing. And Q to get out of this environment. That was set no number to turn off line numbers, set number without the no, we'll turn them back on. And so the actual solution down here, rather than ordering by first name and last name, was ordering by the combined formula that I have of first name and last name right here, or this column actor name. And it turns out when you sort things using the order by, just like in Python or every other programming language, it doesn't actually sort alphabetically, it sorts ASCII-betically. And so the space has a like semantic ordering, and we do this, and now we get the semantic ordering where the space comes after the other things instead of before the other things. Press Q down here. And now this, I think, is my new solution that I want to try. So I'll go ahead and copy that again. In order to paste up here in Vim, I'll have to enter insert mode. You can't just paste into normal mode, because if you do that, it'll try just actually running all of these as Vim commands, and they're not Vim commands, so weird things will happen. So I'll just Shift V to go into visual mode, use my paragraph selection. The curly braces will take me up to the previous blank line, and press X to delete all that, press O, go into insert mode, and paste like that. Save that up here. Now that I think I have another proposed solution that I might work, I want to try it out. Down on the bottom terminal window, I'm going to press Control D to exit my session in the container. It did not stop the container. If I type PS, we can still see the container is running. It just paused or just ended that session with the container, so that I have back on the Lambda server down here, and I'll press the up arrow to go back to my check answers command and hit enter, and we will run all of those test cases. I will scroll up and see that the first problem is in fact now passing instead of failing. So part of doing this homework problem effectively, you're going to have quite a few assignments like this related to Postgres. Quite of doing these assignments effectively is getting good habits using multiple terminal windows effectively, using Vim with multiple tabs effectively in order to easily go back and forth between interactively working on the problem and then running the actual test case itself. Any questions on that? Okay, then let's go on to problem number 4. We're just gonna spend the rest of today going over some of the problems here. I'll just type out the solutions, and as we're going over them, I'll be introducing new SQL commands that you'll be needing for all of the problems. So up here, problem number 4. In my Vim window up here, in order to move on to problem number 4, I'm going to, we'll first try doing :Q up here, and we'll see that :Q only exits one tab at a time and not all of the tabs. If you want to exit all of your tabs at once, it's :QA, the A for all, Q for quit, so quit all. And there we've exited everything. I'll press the up arrow, get back to my previous command, and delete that one, add a 2. And now I have 3 new tabs open, all on problem 2. There's no results. Here's my expected output with the E. The results have no output yet because I haven't added anything to the SQL file right here. And actually, I'm just remembering I said I wanted to do problem 4. So up arrow, problem 4. All of these problems are arranged in a chronologically, like easiest to hardest mode. So while you're working on these, I would recommend going from like smallest number to largest number. The larger numbers will incorporate more SQL commands than the smaller numbers. This problem 4 is introducing something called an aggregate function. And so we're going to take a look at how that works and how to use it to solve this problem right here. Again, all these problems, they have their English statement up here. So count the total number of films whose rental price is less than $1. And then, at least in this first assignment, I'm going to be giving you hints both about the SQL things that you'll need for the assignment, but also the columns and tables that you should be looking at to answer this query. In this case, it's the rental rate of the film table, If we come over back to the Pagilla homework folder right here, then again, there's this entire, this is sometimes called the schema of the database. And the film table over here has a whole bunch of things inside of it, all of the things related to just like what that particular, what we need to know about that movie. And again, this database is like Blockbuster or Netflix, their DVD rental service, all the information that they would need to store in a database. So count the total number of films whose rental price is less than $1. The price for renting things is stored in this rental rate column, and the film table has one entry per movie. Coming down here, I'm going to go back into my interactive pSQL environment, up arrow back to my Docker Compose command. And then I'm just going to take a look here real quick at the film table, get some sense of it. I'll do select star from film like this. And we'll see that this is something like really ugly, hard to read at this point. And what's happening, again, this is called the pager environment in the terminal. A pager environment is like Vim, but it is only read-only. You can't edit it. The outputs from Postgres are something that you can only read. You can't edit. And by default in the pager environment, it shows the entire contents of a line on one line like this. You can use the left and right arrows to scroll. And if you start doing that, then you'll see that it actually expanded the table out into a normal table thing, but it's just expanded now to multiple screen widths. And now you can see that it looks more like an Excel spreadsheet again with column names and various values for the column over here. And so looking at the rental rate, we see like some dollar prices of how much it might cost to rent the movies. And here under the description, is like some information about the different movies. And there's lots of different, lots of different columns here. Again, \D on film will tell us exactly what those columns are. \D is not a SQL command. That is something specific to pSQL. And so it doesn't work inside of any other environment or any other database. We're specifically wanting, so count the total number of films whose rental price is less than $1. So we're needing to look at the rental price column over here like that. Oops, so as rental rate is the name of the column. We know that because I gave you the hint up there, or if we do \D, \D film, we can see the all the names of the columns here. Where did the rental rate go? There it is, rental rate right here. Or again, looking at the schema image up here, we could find rental rate inside the as one of the columns right here. So select rental rate from film like this, shows all of the rental rates. And now we need to, the first thing we need to do is add some sort of filtering based on the price being less than $1. That is in SQL called a where clause. So select all this, and then we add a where, and then we'll only select rows that match whatever condition we put over here. In this case, we want rental rate to be less than 1 because this is all stored in dollars, and this will give us all the movies whose rental rate is less than $1. And you can see over here that they're all just equal to 99 cents. If I press Shift G, it takes me to the bottom of the pager environment. Just like Shift G takes you to the bottom of the Vim environment, G will take you to the top of the pager environment, just like it does inside of Vim. And so you can use that just to get a quick inspection of how many rows matched this query right here. This is not the query that we're going to actually need, though, for our final answer, because our final answer, again, looking at the expected tab, we can see that the answer is 341, but it has to be exactly 341 without all of this other information inside of it. It has to be just this last thing down here. And the The aggregate function, the count aggregate function is what's going to do that for us. An aggregate function will take a bunch of rows, all the entire output of your table, and aggregate all those rows together down into a single row. And so in this case, we want to just count the number of rows that we have. And so we will do count of rental rate like this and hit enter, and we'll get the result being 341. The contents of the count function right here are, or the parameter that you pass to it is very subtle. For our purposes right now, it doesn't matter at all. You'll usually see people do count star like this, which means count all of the rows. If you put an actual column name in there, it means count only those rows which have non-null values. In this case, this particular row of the, or this particular table has no null values in it. And so these two things match and get you the exact same number. The count star pattern is by far and away the most commonly used, like the most common pattern for count. And anytime you are tempted to count the number of rows, whether in real life or for one of these problems, this is probably the tool that you should be reaching for. So now we have something that looks like it matches the output that we were hoping for. And let's go ahead and try it out. Copy and paste this up here into Vim like that. And down here, Control D, exit out of that environment, up arrow, rerun the check answers command. And if we look through that, we can see that number 4 right here is now passing. Any questions? Yes.
Did it automatically make the counts like pattern?
This is a great question. The question is, over here on the expected, there is this count header, and where exactly did that come from? If I go back into the pSQL environment, up arrow back to the previous command, we can see that we are automatically getting this count header. Whenever you have in Postgres a column, so this is one of the columns that we're being output right here, count star. This is a column that's being output. Anytime you have a column that's based on a function, the default name of that column is just the name of the function itself. But we could, if we wanted to, rename that to something like total films. And now that would be the total films column. Usually for aggregate functions, it's pretty rare to want to rename them because just the name count is pretty useful. The main situation that comes up is if you have multiple columns, like in this case, these are going to get us the same results, count star and count rental rate. But if we wanted both of those, now it's ambiguous, like which one's which. And so we would want to have names here to differentiate between the two of them. But by default, if you're using an aggregate function, you probably do not need to use the as keyword to name the column. Did that answer your question? Any other questions? Okay, let's go do problem number 6. QA, exit out, up arrow, delete the 4, replace it with 6, rerun this. And let's take a look at the SQL over here. Here, just the first thing that's jumping out of me about the hint is we still see the count aggregate function, but there's now this new thing over here called a group by, which we'll have to, which we're going to take a look at, explaining what's going on here. And the semantics of this problem lists the last names of actors as well as how many actors have that last name. So here, I'm not actually telling you which table to use here. You have to come over to our schema here and try to figure out, okay, which one, like, does it make sense is going to have the actors' names in it, and it's this actor table over here, down here. And so let's go ahead and back inside of pSQL, \d actor. We can see there's a first name and the last name field, which we already saw from that first problem. And it wants us to know, or it wants to tell it how many actors have the last names. And so let's do a select last name from actor like this, hit enter. And just looking at it like this, it's not necessarily obvious that any actors are going to have the same last names here. But if we change this again, add the order by last name, then we can see that there are, in fact, a lot of actors who have the same last names. Make that even more clear, add the first name as well, just to emphasize that these are different. All these Ackroyd people are different actors. Debbie, Kirsten, and Christian, all different Ackroyds. And what we want, if we come back over here, do a slash. So again, slash inside of Vim is searching for the Ackroyd name right here, just because that's what we were talking about. This is the expected results over here that I'm looking in. And so I wanted to see what is the expected for Ackroyd. And we can see that it is a 3 over here. So how do we get that? And down here, close out of that. That's what the group by is going to get us, combined with the count function. So if I have last name like this, and comma count star. This is sort of what I want, that I want somehow I wanted all the last names in the leftmost column. I know it's the leftmost column because in the inspected, it is listed as the leftmost column. And then I want a count of those last names in the rightmost column, something like this. Select last name, comma count star from actor. And we'll make it a simple command like this. And hit enter. And if you do this, then you'll get an error message in Postgres. Some other databases will allow a statement like this where you have an aggregate function and a column name, but Postgres will not. And the way to fix this is by adding this group by clause. Press the up arrow, type over here group by, and then you have to, in the group by clause, you must list all of the column names over here that are not part of an aggregate function. So here we have last name, not part of an aggregate function. So the group by clause must contain last name over here. We do group by last name like that, hit enter, and we can see there are no error messages. And now we can see that here is this Ackroyd last name that we were looking at before, and it has that correct count over here of the number 3. So again, anytime you want to like count by some sort of subset of things or apply an aggregate function to a subsection of the table, you have to put column names in the column list along with the aggregate function, and the group by clause over here, last name must match whatever is in the group by, must match whatever the column names are over here. Any questions about what that clause did? Yeah.
With this, like, still work, not like get the same outcome, but like what would happen?
Yeah, so the question is, what would happen if we group by without having a count star over here? And the answer is this will give us just the last names. And so group by is a common way to remove duplicates. You won't need to use it for that purpose on this assignment, but in future ones you will. Group by can be used to remove duplicates. And when we get into like what is actually going on under the hood inside of Postgres, we'll see that anytime you have a group by clause, Postgres is going to be sorting all of your data internally and then using a duplicate removal algorithm on the sorted things. If you have a group by with no aggregate function, though, this is extremely dangerous because if you have something like first name right here, so Postgres is being nice and not letting us do this. It is a undefined behavior in general, though. What a SQL engine will do when you have, well, like which of the first names will it select from the group by? Let's go back to our count star like this. And so this is our maybe proposed solution to this number 6 problem. It does what it asked for up here, but it's not going to match the answer because up here we can just see there's a number of differences. The most obvious being that things are somehow sorted up here. The last name count is sorted. And then here we have count versus last name count. So we'll have to change the column names as well. Q, up arrow. There we go. Come over here as last name count. I don't need the double quotation marks because there's no spaces there, so I'm not going to add them. And then we need an order by clause, order by last name count, like that. And now things are ordered, and we have the right columns names over here, but things are they're ordered in the wrong way. So that's not going to work for us. Here, our last name count, what we want is, rather than by default it orders by default it orders ascending ASC. We want to order descending DESC. There we go. And now this looks like it's might be the same results for us. So I'll quit out of that. This is my proposed solution. I will copy and paste that up here into SQL like that. And as I'm doing that, since this is, I know it's starting to get long and complicated, I'll go ahead and just format this a little bit nicer. I like to, when I'm writing long SQL commands, have each column be on its own line like this. And then from actor, any of these major clauses, have those be on their own lines as well. Order by last name count descending. It's a little bit nicer, easier to read at a glance what all is going on. Same exact command though, so hopefully it'll get us the same output. Down here, Control D, up arrow, up arrow, up arrow. Rerun the check answers. This is problem number 6. And so let's scroll up to 6. There we go. We got a pass for problem number 6. Any questions about that problem? Okay. The next one for us to look at is problem number 8. And what's different about 8 is that we're going to have to start using multiple tables at once here, using this join keyword to combine information from multiple tables. And really this, what we're going to see throughout the semester is that this is where the power of SQL really shines in these join keywords. And this is really what makes a relational database relational. Fully talking about join is, well, yeah, go ahead.
Is all this behavior that we're seeing
Yeah, this is a great question. The question is, how much of what we're doing is unique to Postgres here, and how much of it's going to generalize to other database systems that use SQL? The answer is that everything in these next 3-4 homework assignments, everything up to the midterm is going to be things that will 100% generalize to other databases. SQL, Postgres is one of the things that it's famous for is being very close to the SQL standard. By far, out of all the databases that exist, it's the one that most closely follows the SQL standard. Other databases break the SQL standard in certain ways. So I mentioned before that in Postgres, like that group by clause was required. This group by clause right here, this is required inside of Postgres. Because the reason it's required in Postgres is that it's required in the SQL standard. Other databases let you take that away and will still run the command. But everything that we've seen so far and that we'll see over the next couple of weeks works on all databases. When we start getting to the things that are different between databases, we'll start also talking about the motivations behind why different databases made different design choices. And one of the sort of like running theses that I will be arguing for throughout the rest of this class is that the design decisions that Postgres made are really much, much better than the design decisions of other databases. And there's a little bit of another, this high level note over here for us to talk about. I'll do that next time. But I just want to highlight at this point right here that so Microsoft has their own database products. They have 2 of them, Microsoft Access and SQL Server. but even Microsoft uses Postgres instead of SQL Server when they need to do large scale things. If you were to click on this link, it'll take you over to this Microsoft blog over here. Describes an internal Microsoft resource that every time you like bring up the task manager like this thing, you're actually sending data to Microsoft. Actually, your computer's always sending the summary of what your task manager is doing. It's always sending that to Microsoft like once a minute. And so Microsoft has hundreds of petabytes of data from all the billions of machines around the world running Windows, and they aggregate that inside of a Postgres database. And they choose not to use like their own products. This is a good spot for us to stop for today, though. We'll talk about the joins on Friday. We're going to have a normal lecture class on Friday. Will be recorded and uploaded to YouTube. But then the homework will be due on Tuesday. Definitely no extensions on the SQL homework. If anybody has other questions, happy to